All right, angles in the unit circle. Hopefully you should have talked about this last year, but if not, it's okay. We'll get to it. So first we're going to talk about all types of angles. So angles in standard position. So when we talk about standard position, that means that one angle is on the x-axis, the positive x-axis, and the vertex is on the origin. So if you look at like this picture up here, this would be a good picture to draw. The initial side always has to be right here. Okay, it always has to be on the positive x-axis, and we have to be going from the origin. But then the terminal side could be anywhere. So you could have something like, here is that. That could be one, and we could go like this. You could also go this way and have a negative angle. We could have this and like this, and like that could be our angle, or it could be a negative angle. We could even go around a bunch of times, which we'll get to that in a second. Okay, so that is an angle in standard position. The ray on the x-axis is called the initial side, which is that one. And then the other ray is called the terminal side, which is that one. Okay. And then counterclockwise rotation results in a positive angle measure. Now, I am not entirely sure why we do it counterclockwise. I think it's because this is like where x and y is positive, so that's where we start, and then we just go this way. But counterclockwise is a positive angle measure, which means that clockwise is a negative angle measure. Okay. So, and then one full revolution is 360 degrees. So, like, if you were to go around this entire thing, it'd be 360 degrees. Okay. So let's sketch some. So if we want to sketch an angle that's 75 degrees. Well, first, we know that there are 360 degrees in the whole thing. So if I divide that by 4, because we have 4 quadrants, that's going to be 90. So that means right there would be 90 degrees. If I go another 90, it'd be 180. Another 90 is 270, and another 90 is 360. That's also 0 degrees right there. So 75 degrees is between 0 and 90. So I start with my initial side. There's my terminal side, and there's my angle. Okay, what about negative 160? So negative 160, I still start at 0, but now we're drawing a negative angle measure, so I'm just going to go down. So that will be negative 90 degrees, negative 180, negative 270, negative 360. So negative 160 is between negative 90 and negative 180. So there's our initial side, there's our terminal side, and it would be right there. Cool. 430. Okay, so we have 360 degrees in a circle, right? So 0, 90, 180, 270, 360. But the thing with circles and the thing with the unit circle and like all these trig things is they're called periodic functions, which means that they can go on forever and ever and ever and ever. Which means like I could really go around this circle as many times as I wanted to. Okay. And then I could say that angle right there, I went around once, twice, I don't even know how many times, but it would be however many times 360 plus the 90. Okay. So if I want to draw the 430, well, I can just keep going around 90. So that would be 450. That would be 540. That would be 630. That would be 720. So if I want to do 430, that's between 360 and 450. So there's my initial side. There's my terminal side. But then the 430, I have to go all the way around and then back up. So it's going to be that right there. And it is really important that you actually draw like that black swirl. You have to draw that out. Okay? All right, now let's get into radians versus degrees. So a radian is a unit of angle measure based on the arc length. So 1 radian is defined as the measure of the angle intercepted when the radius is equivalent to the length of the intercepted arc. You're probably looking at the computer screen like, what the heck is she talking about? So we're going to look at this. Right, this is a really good graphic. So this right here, see how this is going around? So this is the radius. And then the length of the radius, if I could wrap that around, let's watch it again. So the length of the radius, if you can wrap that around the circle, that right there is 1 radian. Okay, the angle measure that it makes when you can wrap the radius around the circle is called 1 radian. Okay. Where's my PowerPoint? There it is. Okay. So that's what a radian is. It takes the radius, and if you wrap the radius around the circle, that creates 1 radian. So 1 radian is about 2958 degrees. Here is a little thing to kind of show us why it is. So if we have this 1 radian, if I double that, so about 3.14 is pi radians, so that's the top. Because the 56, and you can double it, so if you get 3.14 radians, which is pi, that's 180 degrees. So if the whole top of this is pi radians, that means the entire circle, because the top is pi radians, which means the bottom would be pi radians, so the whole circle is 2 pi radians. Okay. So in half a circle, there's pi radians, which is also 180 degrees. Pi radians is 180, so 1 radian is 180 divided by pi, which is approximately 57.2958 degrees. And you could check that in your calculator if you want to. If you just do 180 divided by pi, it is approximately that. Okay? Okay, so to go from radians to degrees, you're going to multiply by 180 and divide by pi. To go from degrees to radians, you're going to multiply by pi and divide by 180. And the reason is because of this conversion over here. Since 180 over pi equals 1 radian, that's how we're going to convert between the two. Okay, so let's do it. Let's actually convert. So 30 degrees. If I want to change that to radians, I'm going to multiply that by pi over 180. I can put that over 1. So I'm going to have 30 pi over 180 because the degrees cancel each other out. If you have degrees on top and degrees on bottom, well, now we don't have degrees anymore. They're gone. And we have 30 pi over 180, which if you reduce that fraction, you get pi over 6 radians. Okay, this one. So if we have 150 and we want to change that to radians, I'm going to do 150 times pi over 180. Put that over 1. I get 150 pi over 180. Which is 5 pi over 6 radians. Okay, this one, so negative 220, and then I'm going to multiply that by pi over 180. Put that over 1, so negative 220 pi over 180 is negative 11 pi over 9 radians. Okay, if we want to do it the other way, so if we want to convert from radians to degrees, now I'm going to multiply by, instead of pi over 180, it will be 180 over pi. So notice the pi's are going to cancel out, and you get 720 degrees divided by 3, which 720 degrees divided by 3 is 240 degrees. If you have this one, negative 5 pi over 36, multiply that by 180 over pi. The pi's cancel, and I have negative 900 over 36, which is negative 25 degrees. Do one more, so 7 pi over 4, times that by 180 over pi. The pi's cancel, and I get 1,260 over 4, which is 315 degrees. Okay, all right, coterminal angles. So I've kind of mentioned it. Coterminal means that they end at the same place. So the terminal side, they have the same terminal side. So like if we look at this picture over here, we have the angle 120. That ends right there. And we also have the angle negative 240 that ends at the same place. So that means 120 and 240 are coterminal angles. Okay, because they end at the same spot. And if we look at this, okay, so then let's find a couple others. So if I do 120 minus 360, that's where I get the 240. If I do, so if I do 120, so here's 120, and I add 360, so I add a complete revolution, you get 480. If I do 120, negative 240 minus 360, I get negative 600. These are all coterminal angles. So notice all I'm doing is adding 360. So if I do 120 plus 360 plus 360, I get to 840. That is another coterminal angle. So to find coterminal angles, you just add 360, add or subtract 360, which means that there are infinite coterminal angles. We could find an infinite number of coterminal angles. You could just add, so to find the coterminal angles, you take your angle measure, which we'll just call theta, and you add or subtract 360. And then you could do, say, n. For n is, it has to be greater than 1, obviously, but, okay. So give two coterminal angles for each given angle, one positive, one negative. So if we have 65, let's graph it first. So that's going to be right there. Now, if I want to find the coterminal angle, I can add 360 to it. And I get 65 plus 360 is 425. So that's one coterminal angle. I could also subtract 360. So if I do 65 minus 360, I get negative 295, which is another coterminal angle. 540. So there's 540. It's right on the x-axis. So if I subtract 360, 540 minus 360 is 180. That gives me a positive one. And I need a positive and a negative one, so now I'm going to take that 180 and subtract 360 again. And I get negative 180. Okay? Now I have 13 pi over 18. Whenever I'm given it in radians, it is so much easier to convert it to degrees. So let's change this to degrees. Multiply by 180 over pi. Pi's cancel, I get 2,340 over 18, which is 130. So let's graph that. Now to find our coterminals, I'm going to add 360, so I get 490. Subtract, If it's given to you in radians, you need to give it, like you need to give me the coterminals in radians also. I'm going to multiply by pi over 180, which you get 490 pi over 180, which is 49 pi over 18. Now, if I subtract 360, I get negative 230. Multiply by pi over 180. I get negative 230 pi over 180, which is negative 23 pi over 18. Okay, so there's my positive and my negative. Okay, reference angles. So there's also reference angles. So for an angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. What the heck does positive acute angle mean? Well, positive obviously means it's positive, and acute means that it's less than 90 degrees. Okay, so the positive acute angle, that means all of the reference angles are going to be positive and they're going to be less than 90 degrees. Okay, and then if we look at this graphic over here before we even get into this, like in this one right here, this one, so whatever angle is in the first quadrant, the reference angle is going to be just the same angle. But if it's in the second quadrant, the reference angle is right there. The third quadrant, here's the reference angle. And the fourth quadrant, here's the reference angle. It's always with the x-axis. Okay, always, always, always with the x-axis. Okay, so then let's find these. So we want to sketch and find the reference angle for each of these. So 75, that's right there. Now I can drop this down and create a triangle. I think that's the easiest way to do these is to create a triangle, which means theta is right there. That is my reference angle, which in this case is just 75 degrees. Okay, what about this one? So 140 is that, but then I want to create a triangle with the x-axis. So I'm going to drop that down, and there's theta. Now I need to figure out what theta is right there. So if this is 180 and this is 140, well, I could just, to find whatever this angle measure is, I could just do 180 minus 140. Okay, so that's going to be 40 degrees. So our reference angle is 40 degrees. Now 225, so that's right there. I need to create a triangle, so I'm going to drop that back. There's theta. So now 225, I need to figure out what that angle is. So if this is 225, this is 180, and I want to find the distance here, well, I can just do 225 minus 180, and you get 45. Which means our reference angle is 45 degrees. Okay. 330, so there's 330. Create a triangle, there's theta. So now if this is 330, this is 360. To find that distance there, that's going to be 360 minus 330, which is 30 degrees. Cool? The reference angle is always less than 90 and is always positive, which I was saying before. Okay, and here's a little cheat sheet. Write this down. This will help a bunch. So if it's in the first quadrant, the reference angle is the angle. If it's in the second quadrant, it's 180 minus the angle. Third quadrant is the angle minus 180, and the fourth quadrant is 360 minus the angle. Okay? That is all. Bye.